Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night. And we're coming tonight from the shack of VK7 Tango Whiskey, the ISO shack of VK7 Tango Whiskey. And been working from home, which is a novel return to to working from home conditions. So we've been doing actually doing a little bit of radio, heaven forbid. So hello Hayden and hello Jordan. So yes, Hayden, I broke out my what I normally record the broadcast with, the very nice Audio Technica USB microphone. So I took a feather out of your cap, and I hope the audio is such. Using OBS, so Open Broadcast Studio, for those that don't know it, very nice, runs absolutely wonderfully under Ubuntu Linux, and have set up the show as a whole lot of scenes. So I literally need to work my way through these scenes, and we should be there. So we've got a little bit today, and Leigh is also in quarantine. So good luck, Leigh. I hope you're feeling a bit better than what you were. So yeah, very good indeed. Now. What we'll be covering tonight, a little bit more about magnetic loops and some of the things that we didn't quite get to last time. There are some absolutely wonderful websites, simulator websites, and there's one in particular that I want to take you through the process that I used for the magnetic loop that I think I'm going to build. There's a little bit more simulation that I've got to do, but the conditions, how you set up those conditions in the simulator, and then do some adjustments to the characteristics of the loop and find out what actually happens to things like the bandwidth, and the bandwidth is the key thing here. the relationship between bandwidth and efficiency of the antenna, and I'll go through. There is a wonderful paper by Leigh Turner, which is acknowledged, I think, around the world to be the paper you go to. In fact, Steve Adler, VK5SFA, wonderful call sign that, says in his website about his 160 meter magnetic loop that is the article that you need to read at least 3 times. And it's about a 20-page article that I was going to take you through very quickly some of the salient points in there, which I've highlighted in the paper. So, but anyway, so without further ado, if we do this transition, what you're looking at here is the vacuum variable capacitor that I showed in our last ATV night, DATV night. Now that particular capacitor is a 5 to 200 puff range. I purchased it at the Meet the Voice pre-loved car boot sale, thanks to Bryan VK7KWB, who had it already mounted on a board and is driven complete with a little geared drive and some micro switches as limit switches. So done an awful lot of work, and you can see the board that is he mounted his particular loop on. So this is what I've been waiting for. One of the impetus for this, that's probably a good place to start. The impetus for this was very much looking for a directional antenna with some gain for 30 meters, so for 10 megahertz. For those who don't know, I run 2 whisper stations in the shack 24/7. One of which is on 10 meters, and the Smith chart exercise that we went through a little while ago, a couple of DATV nights ago, was to tune up a piece of end-fed wire that I had sitting up in the air for 30 meters, so to improve the reception and the transmission characteristics of that particular antenna for 30 meters. Now that's great, but it's a fixed piece of wire in a fixed direction, etc., etc. So I've been looking for a directional antenna that has a bit of gain, and that's where my investigations led to the magnetic loop. And the key thing about magnetic loops, and I'll go through some of the characteristics that are key to designing a magnetic loop that actually works really well, is you need some sort of capacitor to tune the main loop. And one of the best capacitors that you can actually get is a vacuum tube variable capacitor. Now, these things are worth an absolute fortune if you want to buy them, and they come up in hamfests every so often. I know Steve, VK700, got hold of one. In fact, I took a photo of a very happy Steve at one of the Miena hamfests, where he got his hands on a variable vacuum capacitor, and he had a grin from ear to ear when he found this, and I think that ended up being put into Steve VK5SFA's dual 2-loop 160 meter magnetic loop antennas. And I know the RD that Steve was using that in, he was a huge signal, so and did really well on 160 meters, I think. So anyway, so without further ado, what I will do here is I just want to show you, and I'll leave the link to this in the notes for this particular video. This is Miguel's VK3 CPU's mag loop antenna calculator, and this is a web-based. It's all Java. really nice little application of Java. And what it gives you is a whole lot of variables down here, which include things like the diameter of the loop material, the diameter of the actual loop, the number of turns of the loop. So if it's a single loop or it's multiples of that loop, there's a transmitter power, and then the actual effective resistance of the loop. And it gives you these sliders down the bottom, and there's a couple of other things down here where you can set up, is it metric or is it imperial? What's the material it's made of? So is it copper or is it aluminium? Is it circular in shape? Is it octagonal? Is it hexagonal? Is it square? And that's fascinating to play with, and we'll do that in a little while. And then along the side axes are all of the characteristics that then get measured by these all these different coloured lines in the middle here. So and there's the capacitance, there's the voltage that's generated, which can be a bit scary, the bandwidth in kilohertz, the efficiency in percentage, and then if we go over here, we've got the various resistances and reactances, the Q of it, how many amps are flowing through it for the power that you put in, and then also the wavelength, the actual wavelength of the loop, which is of course well under 1 in most cases. So what I started to play with was thinking about the material that you want to build the loop out of. Readily available material, if you've got tube benders, you've got it made, because you can get together some aluminium tube, and if you can bend relatively large aluminium tube, the larger the tube, it's a fascinating effect, and I'll show you now. One of the characteristics that I came up with was about a 2 meter diameter loop, which is about it's just under a 5 meter circumference, and I wanted to use heliax and half-inch heliax, so 12.4 millimeter heliax. So if we have anything up to probably an inch heliax or an inch tube or something along those lines, so 25 mil. What we can do is move this slider, and you can see it going up, and we'll go to 25 mil. So there's an inch. So if we go to an inch, you'll notice that, and the frequency that I'm interested in is 10 megahertz, which is this line here. And what it does is it plots each of these characteristics, and then it's putting the amateur frequencies, the upper and the lower part of those amateur frequencies in that particular part of the band on these lines all the way through, which is really, really handy. So up here you've got your two, you've got 10.10 megahertz up to 10.15 megahertz. So this is the area that I'm really interested in. And this particular black line is the efficiency in percentage. So with a 25 mil, so an inch, if you can get an inch tube of about with a diameter of nearly 2 meters, the efficiency at 10 megahertz is up around the 83.52%. So really good. If we go up to 20 meters, so 14 megs, you've got, and it's the 14 megs up to 14.35. You're up in the 94 to 95% efficiency range. But if we bring that down, just watch this line, just watch this black line here, if you can see it. As I bring the diameter of it down, you'll notice the efficiency starts to come down. So we come back to my 12. Oops. I'll just move the other one. Just take that back to 2 meters. There we go. That's 2 meters. And we'll bring the diameter to half an inch, so 12.4 mils. We're now at that 10 megahertz band area. We're now down to 74% efficiency. So you can start to see, if I take this all the way up, and this particular slider gets you all the way up to 80 millimeters. So if you've got a tube of 80 millimeters, and this is, some of the professional loops are quite thick, quite large, and you can see why, because if we go up to 80 millimeters at that diameter of 2 meters, you're actually up in the 93-94% efficiency range. So you can see the efficiency goes up, and also if we look at the bandwidth, at this stage it's 16.8 kilohertz. So if we come back to our half inch, let's come back down to 12.4, and our bandwidth has come down a little bit. It's 13.5 kilohertz. So the efficiency, there's a relationship between the efficiency and the bandwidth, which Leigh Turner points out in his paper. So you can do all sorts of things. If you want to play with the transmitter power. Now, what I'm watching here is transmitter power is plotted. Where is it plotted? It's not plotted, but the voltage it generates is plotted, which is this yellow or gold line. So VCAP, so this is the voltage across the capacitor in kilovolts. Now, if you and I've put in 100 watts here as a maximum for a transmitting power. At our 10 megahertz area, we're talking about 5.57 kilovolts. So 6 kV that the capacitor has to be able to stand. If we go up to our 40 meter area, somewhere around here, we're talking about it goes up to above 6 megahertz. But if I want to push that power up, and we'll go to 200 watts, you can see that gold line varies. It actually varies up and down, but you can see it peaks. Well, we're at 500 watts, and we're well over 14 kilovolts. So that becomes a pretty expensive capacitor, because a vacuum tube capacitor to take something like that wattage and that voltage to be able to withstand multiple kilovolts is fairly expensive. So this particular one that I've got is I think it's rated at something like about 5. And I'm not going to be running any more than 100 watts into it. So we're pretty much on its limit here. So you probably would be looking at trying to run under 100 watts. But it's absolutely fascinating. The other thing is here the effective radiation. Now this is also fascinating. This is one of the reasons why you try and bond everything together and silver solder it or aluminium weld it or try and get the resistance of that magnetic loop right down. I've put 0.01, which is probably a bit aspirational, but you can see this bottom scale. If I start raising this up, and let's go to 0.1. 0.1 of an ohm's probably, that's achievable. That's well and truly achievable. But you'll notice in that 10 megahertz range, we've come down in efficiency, we've come down in bandwidth, and our voltage is still is maintained. It's stayed the same. But if we can actually bond everything together, you'll notice our efficiency starts to go up. 0.1, 0.2, 0.02, 0.016, 0.1. So 0.1 I think's achievable, 0.01. If we bond everything together and make sure that it's all silver soldered together. So we're back to our 74% efficiency and our 13.8 or 14 kilohertz in bandwidth. So this just enables you to do the modeling and find out, okay, if I can get, slightly wider tube or some other form of material, and I'm able to actually bend it into a shape, then you can model what you can expect from that particular construction method. Now, aluminium, copper makes a little bit of a difference. If we click on the come on, I'm going to get it right on the. Oh, okay. Let me just go down a bit. That's what it's doing. And we click on. Oh, I'm not able to click on it. Yeah. I just got a. Oh. I just got the notification from Discord. Wondered what it was. Why can't I click on that? That's one thing about this particular Java implementation in Firefox, I reckon. I was just going to show you the differences that that some of the different shapes make. The circular shape is certainly the most. You get the most out of the characteristics that you select from a circular shape. The octagonal shape and I think it's the hexagon shape. It's fascinating watching the voltage because the voltage changes quite dramatically just based on the shape of the actual antenna, which I found absolutely fascinating because you'd think the difference between a circular antenna and a hexagonal antenna or an octagonal antenna is probably not that much, but it does actually change the characteristics quite dramatically. But anyway, I'll post this into the video notes. You can have a play to your heart's content yourself, well and truly, because it's all publicly available. The other thing is interesting to play with is I started to model what Steve Adler came up with multiple. So he uses 1/2-inch heliax. He actually has, I think it's 2 loops. So as soon as you introduce 2 loops, you'll notice we go down quite dramatically in frequency. And if we then come down to about a loop, I don't know what the loop diameter that he uses, but it's probably somewhere around the 1.5 to 2 meters. So this is 1.5 diameter. It's the 1/2-inch heliax. 100 watts, leave that as is. So what we get is 1.8, here's 160 meters, and here's the efficiency. So efficiency is pretty low. We're talking about efficiencies of 0.47 and goes up to about 0.5 at this sort of stage. I'm sure there's other characteristics here that I'm not taking into account, but this is fascinating because you can then, if we say, okay, what if we add another loop, or we make the diameter smaller, so we come back to about 1 meter in diameter, and you'll see we've got even less efficiency here. Voltage across the capacitors, 6.8 kilovolts. And there's some, and your tuning capacitor, that's one thing I didn't point out, is it also tells you what your tuning capacitance should be, would be, and we're at about 318 picofarads, so it's a reasonably large capacitor. I wouldn't be able to do it with the one that I had here. So it lets you, before you even cut some heliacs or cut anything, lets you model what you're looking at. So at this stage, I'm looking at about a 2 meter diameter or 1.9 meter diameter. I'm using the 1/2 inch heliacs. It gives me a range. It gives me about 70 odd % efficiency at 30 meters at 10 megs. It also gives me 14 megs, so it also gives me 20. It does give me 40 meters, although the efficiency is fairly low down, and it's only about 5 kilohertz. And that's probably where it stops. It does give me the other bands here, obviously 80 meters and a few others, but it also at 80 meters the tuning capacitance it's telling me needs to be about 250 picofarads, and I only go to 200. So yeah, it's probably will cover 40, 30, and 20, but it's really the 30 meter that I'm actually interested in. So I'll post this in the chat. Have a play with it. It is a really handy little exercise and modeling tool. So really nice little exercise. So the other one I wanted to show is Larry has done Larry VK7WLH, and hey, we have we have Anthony, we have Harry, and we have Warren from Casey Station. So hello Warren, hi all watching from my office. It's almost 5 p.m. at Casey. 73 from VK0 Whiskey November. Well, welcome Warren, and I've been enjoying the photos that you've been posting to Facebook. And we heads up, we might even get you involved with the WIA Virtual Conference that we're going to go into in a little bit of detail a bit later in the program. So good stuff. Yeah, give us a weather report, Warren. Give us a weather report posted in the chat. That'd be fantastic. Now, Larry VK7WLH has actually done a lot of work and gathered a whole bucket load of information about magnetic loops, and in fact gave us a great talk that is on the Reast YouTube channel. And he sent me a wonderful spreadsheet, and it's actually a bunch of spreadsheets. And hello to Ron. Yes, yeah, we're not R&RF tonight, Ron, coming from yours truly's shack. Yours truly's ISO shack. Now this wonderful spreadsheet, a series of workbooks, enables you to do very similar to what Miguel VK3 CPU can do with his simulator, in a whole bunch of spreadsheets. So you can put in a range, and it gives you all of the factors which are then plotted on the Java application. And this gives it to you in a whole series, the loop calculation. So receiving magnetic loop, you can put in a couple of your factors in here, and it works out the rest of it for you. This is for receiving loops, for wideband loops, and this gives you a whole bucket load of different configurations that this model calculates, and you can take into account. So you can play with different shapes, and it gives you the characteristics. And also, it's interesting. This is LZ1AQ, who's come up with this, and I'll also post the link to this in the video description. Came up with this back in 2013, actually, by the look of that. And has also, in this particular one, he's actually measured empirically some of these different loop configurations. So there has been some real world testing of differences in loop configurations as well. Loop inductance, and that's the formula that is used behind the spreadsheet formulas and calculations, and then antenna factor, which is where I started. So antenna factor for different loop configurations, or how to measure the field strength. And I'll also post Steve Adler's VK5SFA's website as well. In his development of the 160 meter loops, which is an award-winning loop. I think he got a ARRL award for that in one of their homebrew area sections. So congratulations to Steve. But I'll post his website address, because they did a lot of Adelaide Hills, I think it was, or maybe it was AREG, or maybe it was both. Did quite an amount of field strength testing with the actual loop configurations, and I think there was some adjustments made to it to improve the field strength. They were hoisting field strength meters up into trees and all sorts of stuff. So that is actually that particular design has been measured and proved to be quite successful. And I know when I've contacted Steve on 160 meters during the RD contest and a few other contests, he is a thumping signal into VK7. So that the loop works really well, and he was certainly hearing stations that I had absolutely no chance of hearing. So it was certainly working really, really well. So I'll post that. That's another calculator, if you like. Now, let us know when you're running. Oh, yes, okay. Oh, very good. Okay, and Jennifer Folds has just posted that the ACMA awarded my foundation license today, so fantastic. Jennifer, if you can let us know what your call sign is, that would be absolutely fantastic. Warren just makes a comment there. Haven't got my ham shack set up yet, so good stuff. We wait with bated breath, Warren. So yeah, and for those who haven't got a VK0 contact, I'm sure you'll post when you're going to be transmitting, and you'll have an absolute pile up. So what I was going to do now, this is a bit of an experiment. Let me just reposition. VK6JEN for Jennifer. So fantastic. Good stuff, Jen. I love the call sign. Very easy to remember. Good stuff. Now, we'll just head over to our close-up camera. Okay. Now, what I was going to do here. This is, and I'm not going to read all of this, by all means. This is Leigh Turner's, that's a good point. That has quite a different characteristic on the back of the microphone. There you go. Learn something every day. So I'll post the link to this particular paper. It is a very comprehensive paper and is cited by a lot of people. So Leigh is I think acknowledged to be a very knowledgeable person on magnetic loops. But some of the things in reading this that I picked out, I just thought this is where I just noted a few things in the column here, which is less bandwidth, greater efficiency. So there's a definite relationship between the two of them. And for small transmitting loops, the circumference size, so what defines a small transmitting loop antenna, the circumference is greater than 1/8 of the wavelength and less than 1/3 of the wavelength. So that's what they class as a small transmitting loop. So greater than 1/8 of a wavelength, but less than 1/3 of a wavelength. And there's all sorts of things in here. There's a few other notes I noted in here, and he goes into the different types of capacitors. The butterfly type of split stator air capacitors. Then we go into the vacuum variable capacitors. There's a few other. Then he goes into feeds. Now, this is something I was very interested in. There are two types of feeds. There is the gamma match, which the microwave experimenters amongst us will know what I'm talking about there. A little tuned stub. And then there is the Faraday loop. And the Faraday loop, interesting. The diameter it has a ratio of 5:1, so 1/5 of the size of the loop. So this is a loop that is totally isolated from the main loop. It sits usually down the bottom of the loop, away from the high voltage end of the loop, which is where the capacitor is. And it is fed a variety of ways, but it's called a Faraday loop, usually 1/5 of the wavelength that you're looking at. Here's a particular unshielded coupling loop. It is literally just a loop. There is some shielding. Here's the schematic equivalent of a magnetic loop. The coupling loop, the loop inductance is represented from a schematic point of view. There is the tuning capacitor. There is the loss resistance of that particular loop. Taking into account all of the construction method, etc. And so that's the equivalent circuit, and then it heads off down a 50 ohm coax. Now there is some they talk about, and then Leigh talks about the other type of match, which is the gamma match. So this is a small length of quarter wave, etc. Usually with a tuning short, so a shorting bar that you can move and actually tune it so that it is matched to the coax. And you can see here's a couple of examples on some very nicely made loops. There's the shorting bar that goes around the main loop, and then that enables you to move those screws, undo those screws, and move it up and down so that you actually match the loop. There's a couple more examples. So now pattern, the radiation pattern, end on. There's the loop. So you're getting the donut, if you like, out each side of the loop, and I think that might be it. There's a couple of other examples where, he talks about this is that effective resistance, that RE. He shows here there's a butterfly capacitor, and to get that resistance right down and the Q up, he's even gone to the extent of, with an aluminium welder, actually welding all of those plates together, the stator plates together and the rotor plates together, to make sure that absolutely everything have lower ESR losses and higher Q. And these are all aluminium welded on each side of the plates of the capacitor. So getting that right down. Here's a homebrew. This is a copper pipe loop. and you can see they've been silver soldered onto the brackets that are on the top and the bottom of the vacuum capacitors to try and get that resistance right down to as low as you can get. There are plate capacitors. There's another way of doing this where you move the plate one over another. There's also the trombone capacitor, and in fact Jim Tegellas, VK5 JST, uses this in his PEX, in his gas tube. That's the article from AR magazine. That's a trombone which is just uses two copper pipes bent together on a driven thread to move it in and out and give you the variable capacitance. So lots of different ideas, but the key thing is get that effective resistance down to as low as you can, the Q as high as you can, so watch this space. I will let you know how I go. I've got the key elements of it, as you can see. Build this up using the 1/2-inch heliax at this stage, unless someone's got a aluminium tube bender of reasonable diameter that I can actually use. So anyway, so okay, next thing I've been talking about and banging on about, the Pluto. The Pluto is it is an analog devices. Oh, this is really, the focus on this one is really quick. Now, this is a microwave SDR. It's been opened up so that it is from 70 megs through to 6 gigs. Now, one of the things that I researched was originally it only had TX1 and RX1 SMA SMA video on the brain, SMA connectors. Now you'll notice there are 3 other connectors that have appeared on the end of this. Now if I open this up, the one that I actually purchased was the latest version, the Revision C board. And what the Revision C board gives you, if I zoom in here a little bit and move it up, you'll notice that there are some UFL connectors. And I bought some little tags with the UFL on one end, and can I just say UFL connectors are not my favourite connectors. Oh, they're too friggin' small to SMA. So what I have brought out here is, the one that I'm very interested in is the external clock signal, which is a UFL connector which comes out here, external clock. And then there are there's actually 3 other connectors. There is an external clock in, an external clock out, and a clock out, which I don't see a need for, but there is an RX and TX2 connectors on here as well. So I bought them out as well. So when we put the top on, you'll notice that we now have a external clock TX1, TX2, RX1 and RX2. So there is 2 receivers and transmitters in that particular box. So watch this space, and this is for the Langstone project that I showed a couple of DATV nights ago. This is a microwave SDR transceiver. So that's what this is about. And whoops, wrong way. I just thought I came across something now for something completely different, which is what I put in the opening slide. You've probably seen one of these, but I found this in a box. I actually gave this to my old man who was VK5 Tango Whiskey a long while ago, and it's called the useless box, and it came as a little kit. Now the useless box is pretty useless because if you switch it on, it switches itself off. And it's got a little battery in it. It's got a little driven motor with a gearbox, little arm with a micro switch on it, and it's wired in such a way that when you switch it on, it switches itself off. So, and I've seen there's a wonderful couple of videos on YouTube around these boxes where there's 8 of them, and the guy flicks all of these switches, and it proceeds to switch them all off and go back again. And there's even ones where there's a skeleton hand comes out and switches it off, and all sorts of things. So anyway, something a little bit different. The useless box. Anyway, okay, we'll head back to the desk. So that's magnetic loops. So that's the and the Pluto as well. The Pluto I am looking forward to, and specifically for the Langstone project. And the Langstone project is a Raspberry Pi with a touch screen, and it came out of the UK microwave group. A very smart bunch of guys came up with the control surface, the Raspberry Pi control surface, which is all touch screen for that controls basically the Pluto, and the Pluto then the microwave output can then be used for all sorts of things. So that's certainly one of the things that we're going to be playing with in the not too distant future. Now we'll do a bit of a time check. It's 8:18. Okay, what we might do is I'll leave. I was going to go through a few of the remaining articles in AR magazine, because we went through quite a few of them last week, because there was lots and lots of VK7 content, thanks to Rex and Richard and a few other people. So yeah, I was going to go through the other, but I'll leave that until a fortnight. But what I will do though is we've looked at this particular website a few times. This is the Webb, the JPL, so the Jet Propulsion Labs. This is their James Webb Space Telescope Where is Webb website. And it tells you, initially it was getting the spacecraft to the Lagrange point number 2, which is well and truly there, and you've probably seen in the news that they have been posting some pretty amazing stuff as they've been aligning mirrors and all sorts of things. Well, what they've been doing is all outlined here. So image stacking, coarse phasing, the fine phasing, which is what they did just recently to produce that incredible picture of a well, it was more than a star. It was a whole galaxy, but it was billions of light years away. It was just scary, a long way away, not billions, but a long way away. And then they've continued to do the telescope alignment. They are just in what they call the cryo cooler final countdown. This is where they are right at the moment. They're just about to do the final correction and then the instrument calibration, and we will start seeing, I suspect, some absolutely phenomenal pictures start to come out of the James Webb Telescope. Again, this is let's go to metric. The temperatures out in space are scary to start with, but the difference between the hot side and the cold side of this telescope, we're at the hot side, which is the side that faces the sun. We're at somewhere between 13 degrees C and 53 degrees C. And on the cold side, so the bit that looks into space, is minus 230 degrees. So the differential here is phenomenal. And I don't know how some of the equipment and some of the electronics in that can stand. It is obviously very well insulated, but can stand a differential of scary amounts of temperature. So, but yeah, It's a good little website. I'll post it in the link below, and it tells you this is where they are at this point in time. Everything's gone to plan to this point, which is fantastic. So really looking forward to some fantastic pictures coming out of the James Webb Telescope in the not too distant future. Now, Warren's actually working. Good stuff. Now a reminder. Some reminders. One of the things. Oh no, I know what it was. One of the key reminders here is the WIA Virtual AGM. Now let me just make sure that I have this media source. Sorry, I should have set this up before. And window capture. That's what I want to do. And let's have a look at the WIA conference. All right. Okay. The website, the WIA website now has over here the WIA 2022 virtual conference that was put up a day ago, thanks to Robert VK3DN, the website, the WIA webmaster. So it's good stuff. Thank you, Robert. Now, how to participate? You can come along. You can watch it on streaming via Zoom, and thanks to UTAS and Hayden, who are the movers and shakers in that area. You can also, if you happen to be in Hobart on May the 7th, you can come along in person to the Aurora Lecture Theatre at IMAS. And if you go down to the bottom here, register today. That's the register link for Eventbrite. And if you're in Hobart on the 7th of May, come along to the Aurora Lecture Theatre, IMAS 20 Castro Esplanade, and there is how you get to it. The Google Maps image shows you the wonderful brand spanking new IMAS Lecture Theatre, and it's literally straight in this entrance here. So there you go. So the let me just close that off. And ooh, that was a bit nasty, wasn't it? Let me just get that back again. I've closed it off. Okay, that's all right. That's my my mistake for the running OBS. You have to forgive me for that. So the WIA AGM, May the 7th, it will be. There are 4 presentations. Starts at 1 o'clock. 1 o'clock, and then runs through until 5. That's Eastern Daylight Time. And we've also put in the there is a flyer that is on that website that I showed just then, and I'll put the link in the description. There is also the time zones for the Australian Western Standard Time. Sorry, my fingers are in the way there. Australian Central Daylight Time and also Australian Eastern Daylight Time will be out of daylight saving by then. So there's all the times there, and so it runs from 1 till 5. Eventbrite registration, please, even if you're coming along, The cost, there is a small cost, a cost of $10. So only a very small cost, because we've got some costs that we have to cover with the hire of the lecture theatre and the streaming arrangement. So, but $10 for what's that? 4 or 5 hours of presentations on Antarctica. History presentation, all about running the Antarctic Division with Rex VK7MO, all about the atmospheric research and studies that's going on in Antarctica right at the moment and in the past with Dr. Andrew Klikachuk, and then a bit of a review and some of the challenges that face doing communications, which Warren will be coming to grips with as we speak. In fact, he's probably off fixing something right now. By Peter Yates, VK7PY, and Kim Briggs, VK7KB. So that's the full presentation. So it should be a fantastic day. So now, next week we don't have a DATV night because it's the first Wednesday of the night and we have a presentation night. The presentation is being given by VK7AJ, Andrew Johns. Now Andrew, when he's not working for Telstra, he is flitting about the country doing broadcast audio for some of the very biggest sporting events that are in Australia. This is AFL, this is Test Cricket, this is BBL, this is WBBL, this is AFL, AFLW, this is the various basketball codes, etc., etc., etc. So the list goes on, and Andrew, as an audio technician, gets to play with some pretty impressive equipment and technology that rolls into town when these things hit town. And he's telling us all about that, along with a whole lot of pictures. And it's even more poignant given what's going on right now at the MCG in tribute to Shane Warne. So he has some stories about Shane Warne, so some great ones. So good, not to be missed. It's in the Queen's Domain club rooms. It will be streamed, so you can get you can certainly what's this about? Yeah. Oh, correct. Well, there you go. Just had a text from Alan, VK7KWB. And just to prove, this is exactly, that's a photo from Casey. Casey stationed down in Antarctica, compliments of one Mr. Warren VK0, sorry, Whiskey November. Sorry, Warren. Oh, dear, oh dear. A very sought after call sign. So wait until you get on the air. You'll be absolutely overwhelmed with people wanting to contact you. So good stuff. And then spend the next 10 years doing the QSL cards. Hi. Anyway. So that's our show for tonight. We finish, excellent, right on an hour. So now we don't have videos tonight because it is being streamed from the shack. So no videos tonight. Apologies. And a big hello to all those people up at the Queen's Domain club rooms who may or may not be watching this and coming from the ISO shack. So we'll have another program next time. So 73 from VK7 Tango Whiskey's ISO shack. Here we go. See, from the ISO shack of VK7 Tango Whiskey. And now for something completely different. So 73, and we'll catch you next time. Cheers.